Today we're integrating the Snyk security scanner into a GitLab CI/CD pipeline. And while we're at it, we'll test how well AI can write secure code. Our guinea pig is an e-commerce app entirely coded by AI. No tweaks from me, so it's 100% AI generated. To keep things interesting, I use the exact same prompt with both Google Gemini and GitHub Copilot. That way we can see how their outputs compare. Here's the prompt I gave them. Make me a simple e-commerce app with login and registration, a personal details page, e-commerce features like a product catalog, shopping cart, and checkout, and admin pages with user and content management. Use Python and PostgreSQL as the tech stack. I also made a variation of the prompt using Node.js with MongoDB to see if that stack performs any better. You can find all the code right here. Now, a quick heads up. I didn't verify if it's a fully working website or anything, but as you'll see, it actually makes for a pretty realistic experiment in the end. The code's already pushed to GitLab, so let's jump right into setting up the pipeline. Alright, let me just tidy up this code a little bit. We're using a Python image based on Alpine Linux. It's lightweight, pretty popular, and works great for this pipeline. I like it because I'll be installing stuff with both Python and NPM, and installing NPM in Alpine Linux is easy. Now, some folks might argue that a smaller image is always better, but that's not the full story. If you're curious about how image size really impacts performance, definitely check out my video on optimizing CI/CD pipelines. Okay, now getting back to what we're doing here. So, the first thing we need to do is get Snyk installed. There are a few ways you can do this, but my personal go-to is the Snyk command line interface, or CLI. The reason I like it is because the configuration is consistent across all CI/CD services, which gives you a nice universal approach. On this page here, you can see all the different installation methods for pretty much every operating system out there. You can grab the executable using curl. Just make sure you're using the correct URL for your OS and processor. Another option is to install it via Homebrew, and if you're on Windows, you can use Scoop. If that's not your style, you can also go with NPM, Yarn, or even run Snyk as a Docker container. Lots of options, but we're going to go with NPM because then we don't have to worry about the underlying OS or CPU architecture. The setup is pretty straightforward. First, we install Node.js and NPM. Then we install Snyk and the HTML reporter. Now to actually run these scans, we need to authenticate Snyk. Let's pause here for a sec and see how you can snag your authentication token. Head over to the Snyk.io website and log in. Once you're in, go to your account settings, and you'll see the authentication token section. Just click in that text box and copy your token. Then jump over to your GitLab project settings, find CI/CD, and then Variables. Click on Add Variable. You've got three visibility options: Visible, which shows in logs; Masked, which hides from logs but is visible in GitLab settings; and Masked and Hidden, which I'm using. It's the most secure, ensuring only someone with Snyk web access, like a security team member, can see the token, not regular devs. Go ahead and choose a name for your key, something like Snyk token, and then paste the token into the value field. That's all there is to it. I have already done that, so I'll hit the cancel button. Now you can use the Snyk token variable in your pipeline, and it'll be hidden from everyone. Next up, let's do a quick Google search to figure out what we need to scan a Python project. Looks like we need to add a parameter for the Python command, and before we run the scan, we need to install the requirements file. Alright, looks like our first version is ready. This is going to run an open source scan, so let's fire it off and see if we got the installation right. It's generally a good practice when building a pipeline to start with something simple and then gradually add more complexity. Later on, we'll add code scanning and HTML reports. And the job succeeded. Nice. Looks like it didn't find too much yet, but let's move on and add the code scanning, which is the proper static application security scan. First, let's add some reporting by including a parameter for JSON format, and then piping that output to the HTML reporter. And the next line is where the magic of code scanning happens. While the open source scan checks things like if your dependencies are outdated, the code test parameter actually digs into your code to find security vulnerabilities, like missing input sanitization that could lead to remote code execution or path traversal attacks. In addition to the OSS and code scans, Snyk also offers container scans and IAC scans, which is infrastructure as code scanning. We don't need those in this particular setup, but depending on your project, definitely play around with all the different scan parameters Snyk has available. Our scans are all set, so the only thing left is to define the artifacts of our pipeline so we can actually see the test reports after the scan runs. The when parameter needs to be set to always so that we can see the artifacts even if the pipeline happens to fail. Especially then, we really need those reports. Looks like everything is ready to go, so let's hit that commit button. Integrating a static security scan into your pipeline is really this easy. Uh-oh, we got an error. Looks like the scan actually found some vulnerabilities. Let's click the Browse button to see what we got as artifacts. Alright, looks like we've got 5 security issues flagged. Open redirect. Unsanitized input from a web form flows into Flask redirect. Cool, so we actually found something. Before we dive into all the test results, I want to quickly show you an alternative approach. You can also import your development repository directly into the Snyk.io web page. Just head over to Integrations, and you'll see a bunch of different source control systems listed. We're using GitLab, so we'll pick that. I've already got GitLab configured here, but if you haven't, clicking this button will first take you to a GitLab login, where you'll need to grant Snyk the necessary permissions to import your repository. After that, you'll see a view where you can select which repositories you want to scan, and then just click Add Selected Repositories. This will kick off an import process followed by a scan, which usually takes a few minutes. I won't run it now since I've already done it. So, those are the 2 main ways you can use Snyk for scanning. Now for the big reveal, let's analyze the scan reports. We'll start with the last one. The e-commerce app built in a Node.js environment with a MongoDB database. Looks like the package JSON was clean, so the open source scan didn't find anything to report. But then the code analysis, the scan using the code test parameter, flagged 4 issues: information exposure, allocation of resources without limits, cross-site request forgery, and sensitive cookie without secure attribute. Not bad. 4 issues in a pretty small and simple initial codebase is actually quite a lot. Let's move on and see what Gemini cooked up for us with Python and PostgreSQL. Here's the code analysis report, which we already saw. It found 5 issues related to Flask Open Redirect. Snyk provides really helpful reports with a ton of extra information, like how you can actually fix the issue, and you can also find links to the Common Weakness Enumeration CWE pages for even more in-depth details about the vulnerability. Now, let's check out what Snyk had to say about the requirements file. We've got infinite loop, incorrect behavior order, remote code execution, allocation of resources without limits, inefficient algorithmic complexity, and finally, a directory traversal. That's 11 issues in a tiny codebase. Yikes. And finally, let's take a look at the e-commerce app created by GitHub Copilot using Python with a PostgreSQL database. Interestingly, the code scan on this one came back almost completely clean. There was only one finding: use of hard-coded credentials. Everything else was apparently beautiful and secure. But the real story lies in the requirements file. Copilot built the app using Django, and almost all of the listed libraries were outdated and riddled with known vulnerabilities. So, even without any major flaws in the code itself, A malicious actor could potentially gain sensitive information just by exploiting these outdated dependencies. So, in conclusion, it's pretty clear that AI-generated code absolutely needs a thorough security scan afterwards. Even with a really small number of code lines in our examples, we still uncovered a significant number of vulnerabilities. And personally, I think there's always a chance of configuration mistakes or small human edits creeping in as well. That brings us to the end of this tutorial. I really hope you found it helpful, and if you did, please share it with your fellow developers. Thanks for tuning in, and I'll catch you in the next video.